Alright, so we still have the properties of quality up here that we've been using all along. Properties of congruence with reflexive, symmetric, and transitive. You see it twice because there's a difference between equality and congruence, but they're doing the same thing. We've talked about definition of congruence when it came to segments. Now we can use it with angles. Do you see how they have measured angle A equals measured angle B? Angle A is congruent to angle B with an arrow going in both directions. Everybody see that? Okay. That's an if and only if statement, meaning you can switch these two. So I could tell you that the angles are equal and you would know they're congruent, or I could tell you that they're congruent and you would know that they're equal. Just means you can flip-flop the if and the then, and it's called an if and only if statement. Similarly, the definition of a right angle, so to prove if you know that an angle is a 90-degree angle, then you know that it's a right angle. And the opposite is true. If you know it's a right angle, then you know that it equals 90 degrees, so it's an if and only if statement as well. Then you have definition of complementary, definition of supplementary, angle bisectors. An angle bisector divides an angle into two equal parts. Definition of perpendicular says that a perpendicular line form right angles. So if you're in a proof and you know that two lines are perpendicular, you can then state that they are forming a right angle and then go to the 90 degrees. You can't jump right from perpendicular to 90 degrees. Even though we know that in our head, we still have to state that out one by one. The angle addition postulate, you're going to see that a lot in these proofs. Just like segment addition, you're adding the two parts to equal the whole. We did that in chapter 1. You guys already know that vertical angles are congruent. Now notice that the arrow is only going one way. If I tell you that two angles are congruent, that doesn't mean that they are vertical angles. So you can't flip-flop that. It's not an if and only if. Complement theorem. This one would be new for you. This is saying that if two angles form a right angle, then they are complementary. That's called the complement theorem. We've talked about the idea, but we have not talked about that actual theorem. And in fact, we really haven't had any theorems yet. A theorem needs to be proven. And I believe we have a proof that will prove that. Linear pair theorem. We've talked about linear pairs. The theorem says that if two angles form a linear pair, then they're supplementary. So again, in a proof, if I tell you that two angles are a linear pair, you can't jump to the 180. You have to say that they're supplementary, and then by definition of supplementary, they get up to 180. These two, it's called the congruent complements theorem and the congruent supplements theorem. What the congruent complements theorem says, if two angles are complementary to the same angle, then they are congruent. So think about what that's saying. If two angles are complementary to the same angle, then they are congruent. Maybe explain that one? How does that work? Two angles are complementary to the same angle. Why are they congruent? I would love to. Can you say that again? And then I'll restate it. Complementary is 90. They're not the... They're very similar, just a congruent, complement, congruent, supplement. So it's saying if two angles are complementary to the same angle, then those two angles have to be congruent to one another.
So, yeah, but don't they, so those two angles also have to add up to 90 because complementary is 90, right?
Not the two angles you're talking about.
Oh.
Let's put some numbers into it. So down below, I write congruent. Here, write that down below. Congruent. Complement. An example. If I say that angle A and a angle who's 37 degrees, I'm just going to call it the 37 degree angle. Angle A and 37 degrees are complementary. And I also say that angle B and the same angle, so this has to be 37, are also complementary. And I'm saying that A and B have to be congruent to one another. Why would that be? Somebody explain that to me.
Wait. Repeat that one more time.
Okay. So angle A and an angle whose measure is 37 degrees are complementary.
Yeah.
Also, angle B and an angle whose 37 degrees are complementary. Why do I know A and B are congruent?
Because the other angle is both 37.
Yeah, so what would angle A have to be?
Let me see. Can we just?
Yeah, it's not too
So
like out there.
53?
What's that?
53?
Yeah, angle A would have to be 53, right?
Yeah.
What would angle B have to be, Nathan?
53.
Right, angle B would have to be 53. So what the theorem is saying is that if you know two different angles, are complementary to the same angle, they have to be congruent. Which that makes sense, right? Because they have to add up to 90, so obviously these two would have to be congruent. Similarly, it's saying the congruent supplements theorem. If two angles are supplementary to the same angle, then they are congruent. For the same reason, now you just have 180 rather than 90. So if they're both supplementary to a 37-degree angle, do the math and they have to be congruent every time. Does this make sense to you now?
Yeah. No, it's always made sense to me. But I was just making sure.
Yeah, that's
Right.
So if I don't explain it, it gets weird in a proof. So everybody got that in your head? If you prove that two angles are complementary to the same angle, then you can prove they're congruent. Or throw in the word supplementary. What I would like you to do is justify each statement below using a property of equality, property of congruence, definition, postulate, or a theorem. So you have a theorem now. I'll leave the reference page up on the board while you work your way through numbers 1 through 12. Alright, number 1. If angle C is a right angle, then angle C equals 90 degrees.
Definition of right angle.
Very good. If x is supplementary to y, and x is also supplementary to z, how do I know angle y and z are congruent?
Transitive property.
Not transitive. Dex?
Congruent supplement theorem.
Very good. The congruent supplement theorem. So if the phrase is talking about supplementary and it ends in congruent, it's congruent supplement theorem. If it's talking about complementary and it ends in congruent, then it's congruent supplement or congruent complement theorem. Number 3, where did you guys get there?
Vertical angles.
Very good. Vertical angle. This one's now a theorem. How about number 4? If the measure angle P plus the measure angle Q equals 90, then P and Q are complementary.
Definition of a complementary.
Very good. Number 5, if M and N form a right angle, then M and N are complementary. But we didn't really talk about that one. Did you find it?
Definition of right angle.
No, it was actually a theorem that we really didn't talk about.
Complement.
What did you get? What did you say, Zach?
Complementary.
Complement theorem. Yes, it's called a complement theorem. If two angles form a right angle, then they have to be complementary. It's called the complement theorem. Number 6, what did you get there?
Definition of perpendicular.
Yeah, so if you know L and M are perpendicular, then angle 1 would have to be a right angle by definition of perpendicular lines. Number 7, if W and X are supplementary, then W plus X equals 180.
Definition of complementary.
Not complementary, but
Oh wait, not complementary. I wrote the wrong one. Oh.
it happens. Supplementary. Number 8, if L is complementary to N, and N is also complementary to M, then how do I know L is congruent to N? Very good. It's the congruent complement again, if you have two angles complementary to the same angle, they have to be congruent. Congruent complement theorem. Number 9, if angle A and B form a linear pair, then angle A and B are supplementary. Very good. Linear pair postulate. Or theorem. I'm going to say theorem.
Oh.
I've seen it both. Postulate or theorem, depending on which
So I got that one right.
Yeah, that's okay. I always learned it as a postulate. Nowadays, they're calling it a theorem. Number 10, if N and P are complementary, then how do I get N plus P equals 90? Very good. Number 11, give me the diagram to the right. How do I know the measure of angle JKM plus the measure of angle NKL equals the measure of angle JKL?
Angle addition postulate.
Very good. Angle addition postulate. And last one, if the measure of angle R equals measure of angle S, then how do I know angle R is congruent to angle S? Definition of congruent angles.
I just got some of you
But with angle proofs now. So you look at the first one. It says that angle PQR is a right angle. We're trying to prove that PQS and SQR are then complementary. We're really proving the complement theorem.
Wait, do we have to like that?
Yeah.
It's gonna help you out. What is this?
Alright, so a theorem, we talked about a theorem has to be proven. A postulate is a statement accepted without proof. I just want you to know what theorem are we actually proving here, and in this case it's the complement theorem. It says that two angles form a right angle, then they are complementary. Proving the complement theorem.
Proving? Okay.
Alright, so we have angle PQR and it's broken up into angle PQS and SQR. We're given that angle PQR is a right angle, so what's my first reason? Yes, very good. If an angle is a right angle, what's the measure? Very good, so how do we know the measure of angle PQR is 90 degrees? Very good, definition of right angle. We went from statement 1 to statement 2. What about statement 3? What is it? Measure of angle PQS plus the measure of angle SQR equal to PQR. That came out of nowhere. Mason.
Definition of a right angle?
No, there's nothing about 90 or right.
So look at what it's doing, like actually like mark it off on your paper.
PQS.
Wait, I got the.
What do you know? Go ahead.
It's angle addition.
It is very good. The angle addition postulate. Just like the second addition postulate, it also kind of came out of nowhere. Alright, so then statement 4 says the measure of angle PQS plus the measure of angle SQR is equal to 90 degrees. That one's coming, I'll tell you, from statement 2 and statement 3 both.
Is it?
No?
Definition of complementary.
They switch something out.
Alright, so let me circle something different. PQR and PQR.
Substitute.
Almost. Transitive, very good. That is the transitive property.
No, the bottom one.
And what was my common link? PQR. They linked it together by the measure of angle PQR. Now let's do from 4 to 5. How do I I then know they're complementary?
Definition of a complementary.
Very good, definition of